Welcome to the Renaissance Charge 4 DualPole motor Energizer kit, and we're looking at a voltmeter, an amp meter. This is the primary battery, this is the charging battery. We're going to look at the schematics. There's three different sheets. This is the primary sheet here that we're going to look at. The first circuit that we're going to look at, the way it's hooked up right now, is here. So we have one primary battery and one charging battery. So there's the primary battery that powers it. There's a charging battery, and that is separated from the generator coils, which also can charge batteries. And that is a third battery, or we're going to do 24 volts for a larger battery bank. Now let me just say while we're talking that this charging battery can be higher than 12 volts, could be up to 300 volts, depending on the transistors you use, so forth. So right now we're just running this at 12 volts input, 12 volts output, and the generator coils, the 4 generator coils, are mounted every other coil here, and they can again charge batteries, which we're going to look at shortly. So we're going to run this with an amp meter going to the primary battery across the negative terminal here, going to this amp meter, and then we'll show some voltages here. Again, there's going to be some options that we can do afterwards. We can run some LEDs instead of charge batteries. We can go to a bridge rectifier to charge batteries, or we could run through a transformer the output, say your ignition coil transformer, and power some fluorescent light bulbs if you want. So we will look at options 1, which would be the first alternative would be just to connect the output, close it off, so to speak. Instead of it going to a battery, we're going to just connect both legs where it says charging, connect these together. Now again, make sure that you don't leave that unconnected, because it will blow out the transistors immediately. So either connect those positive and negative terminal together, as we show right here with the black line, or connect them to a battery, as in this alternative or the first one. So the second option would give you the output across the coils going to a bridge rectifier, then being fired or charging up a capacitor, which we provide right here. It's a yellow capacitor, non-polar capacitor, so it doesn't matter which side you're doing. And then an SCR triggered by either a neon bulb or a diode charging batteries. Could be 12, 24, 36. It's limited to about 70 volts. Well, actually no, on the generator coils, if we do this arrangement, you can go up to about 70 volts, whereas on this arrangement you could go up to probably 300 volts. So this is pretty straightforward in the instructions. And then option 3 would allow you to place diodes across each coil. We provided 48 LEDs. And you can see they're going either direction because you have a sine wave here, so you can go both directions. These LEDs do not allow for the both directions, as they have resistors and diodes in them to prevent that. But the ones that I provide in the kit, we've got 12 red and 36 white LEDs, could easily be powered across the motor coils. And then you have one 12 volt battery. Fourth option would be to run the output through a primary of a ignition coil or another similar transformer, and then power a suitable load with fluorescent bulbs. I don't show that in this video because it's an option that you can experiment with. We'll show that later on in other videos coming up. We've showed that in other videos running other motors. It's the same circuit, same kind of system. So let's look at a few things here. Again, we're going to be running the generator coils powering LEDs here, and then we're going to have a switch here that transfer over to charging batteries instead. And we're not showing the fluorescent light bulbs running at this point, but I'll explain how this all fits together as we go along. But the first thing we want to do is look at the amps being pulled from the primary battery, and we can look at the voltages. Let's get another voltmeter going here. So we're going to look at the primary battery voltage, which is 1213. Then we're going to look at the charging battery voltage, got to be careful that these clips do not come off, which is tending to happen here while you're running. So this battery is at 1124.24 volts at rest. It's been resting for 4 or 5 days here. And now what we're going to do is simply turn on the switch that we're providing in the kit, and that is across the that switch is right on the primary negative side right here. Actually, no, sorry. It's on the positive side, going to the coils from the battery right here, actually. So I'm going to turn the switch on. Note my reed switch plate, which we'll go over in a minute, is slightly advanced. Whatever way it's advanced will turn on. You'll notice the bouncing effect, and you'll see it pulls good 6-7 amps to start, and it goes down. Of course, we got it backwards, but that's alright. So now what we'll do is move it closer to the center. Ouch. And you'll see the amps go down. So right now we are not doing anything in the way of with the generator coils, but we are charging batteries. You can see this battery right here has moved up and is charging. Primary battery is going down because it's mostly discharged or half discharged, drawing almost 2 amps. Has pulled this battery down. If I turn it off, you can see it sort of bounce back. Of course, so the battery's about half drained. This one's mostly drained. And now we can look at the charging option, which we're going to look at right here. So we're going to have a third battery from this generator coil. All the generator coils actually are in series, unlike this parallel arrangement here. They're in series with each other to bring higher voltage. And I'll go over that in a minute, the details of that. But what we're looking at is charging up this capacitor. Right now this switch is, the generator coils are coming in to this terminal, and I'll show you those connections in a moment, and then they're in series with each other, and the total is coming to this bridge rectifier, which is shown right here, and you can see the positive is right here on the outside, and the other one's the negative, and the two middle ones are the AC terminals, which the wires connect to. You can see another close-up here, how it's connected. Negative on one side, positive on the other, the AC connects there. We'll show you that in a minute. But what's going to happen now is you can notice the amps, and what we're going to do now is look at this battery. So it's at 1248, and it's connected here. This white wire was connected to the primary to back charge the primary, but we'll show you that later. Alright, now we're going to look at this battery. Notice 1248, 1247, and now we're going to be charging it. Now watch, did you see the amp draw go down on the primary battery and the RPM sped up? So we are actually putting a load on this, and it's actually speeding up and drawing less energy. So one other way of doing that would be, and that should charge the battery in a minute. You can see it's 1249 already going up. So let's go over instead. See, now I'm going to disconnect it. You can see the amp draw go back up. And what I'm going to do is go over to the primary battery. And again, the amp draw went down because it's drawing less energy, it's charging up the primary battery. Now the problem, or the benefit, a greater benefit would be to charge up another battery. As you can see here, we're reducing the amp draw, but we're not charging a third battery. So better yet, let's do this. Let's charge a battery, draw less amps, charge a third battery instead. And again, I'll remove this white wire there. So that's one option. Let's look at switching the switch to run these LED strips here. Now I'm just going to simply turn it to the center. We'll turn it off. So you notice the amp draw went back up. RPMs went down. Now I'm going to turn on these lights. Let's turn off the light in this place and see just how much light we're producing. Notice the amp draw went down considerably more, and of course we're not charging this battery anymore. Let's take a look at how the lights look. So the other thing I want to do again is flip this switch and watch the neon bulb if you can. Actually, hold on. Yeah, so you can see how bright it is. These are at full brightness. And another thing I'm going to do is, I want you to notice the neon bulb here when I turn the switch. I'm going to turn the switch off and switch it over to charging the battery now. Let's look at, first of all, make sure we're connected up. Okay, now what we're going to do is let the neon bulb switch this SCR for a high voltage pulse into this third battery. And, oops. So, Now you can hear the ticking. So what's happening is this neon bulb right here, let's see if I can get a close-up on that for you can see it barely flickering here. See right, you can see it right here flickering. Now watch when I turn the light out. You may be able to see that. Yeah, the bottom of the screen there, the corner. Okay, so what's happening there? Put all the lights back on. Notice for one that the amp draw has gone up on the primary battery because this is not really producing a great load on the system. So it's almost like we're doing nothing. But we are charging this battery. You want to look here. See 12, 48, 49. It is charging a little bit. And this is good for running various loads of a higher voltage battery bank, and to just really hit that battery hard with a higher voltage. Make sure we go back out here. So you can hear it ticking. That's every time this voltage in this capacitor gets up to 60, 70 volts, which I'll show the AC, then it ends up firing that neon bulb ends up firing and turning on the SCR. SCR is just like a diode and a transistor in one. So let's look across the input. The input from the generator coils is 52 volts. So at 52 volts AC, this neon bulb is starting to fire, and you can see, if we go back to DC, let's look at the output, which is across the bridge, the positive and the negative of the bridge. You can see it's 56. So you notice how it fluctuates because it's getting pulsed. And that, again, what I was doing was across these two terminals here. This is the positive and that's the negative. So we're looking at that voltage, and then the voltage over the battery, which is here and here, is 12.48. We go back and see 12.49 now. All right, so if we switch the switch down here at the bottom, which I haven't included in the kit, but it's up to you how you put these together. I'm going to show you that again on this. There's a little diode here, 1N4001 or 7 diode is the other option now. And that's going to put 1 volt across the battery, 1 volt higher than the state of charge. So let's go and flip this switch. Now you can't hear the clicking anymore because it's a lot more rapid. Now look at the amp draw went down because we're actually pushing more into the battery. So let's look at the voltage across the cap. Now it's 13.5 volts DC. And let's look at the AC. 16 volts AC. And let's go back to the charging battery. 124950. It's already charging up that fast. All right, so that's one option for the generator coils. Now you could also, I said, run LEDs across the generator coils as the output, or you could even do maybe the fluorescent light bulb. I'm not sure if it's powerful enough. If you had a small transformer, maybe. So we can either run, as I said, on the output, various loads, AC and DC loads. Just showing you a couple examples here. And you can see the charging rates, how they differ. one from another. And then of course if we go back to this battery, we can see that it's been charging the whole time. So there's two sets of charging possible here. So 1177 going up. Again, if we switch this to the LEDs, that charging rate is going to be affected too. See, that's gone down now. Less input, less output in that respect. But on the other side, it's interesting, while I'm charging that third battery, the input drops. Alright, so let's look at a few more things here. One thing that we could do again is run, you can see these LEDs here. These ones are the red ones, and these ones are the white ones. And you can see their arrangement. Notice how the anode's connected to the cathode all the way. You have to get the polarity right here. And then you can go one whole way, one way, and then you can go the other way, the opposite way, each coil. Because there's a sine wave there, two sides of the sine wave, and only one side with each LED. So you want to experiment starting off with the maximum number of LEDs and work your way down because you don't want to burn them out. But you can see how I've connected them together, and there's a whole bunch provided in this kit here. So let's go over some details. Let's turn this off for a second. Well, before I do that, you can see as I put a load on it, it does draw more. But the power is available right from the bottom, and there's quite a bit of it. And depending on the timing. See, it's drawing a lot more as I advance it more. See, the coils also, the coils being positioned close to the other coils pick up the radiant energy, as we call it. So they are affected by the RPM as well as the charging rate. So this battery is not going to receive as much charging in this scenario while there's a third battery being charged or the LEDs are being used. So it's a sort of a give and a take situation. Alright, so notice I'm turning it clockwise, and if I turn the timing plate the other way and stop it, now it's counterclockwise. And again, we'll move it more towards the center. We don't want to have it exactly top dead center to start because it won't know which way to go. So this gives you the ability to switch it either way with no problem, no changing of any circuitry. And again, it's pretty hard. So it goes either way. Tick, tick, tick. Alright, so we've only provided one of these switches, and we haven't provided this in the kit simply because we don't want to put out too many parts. You can buy these all together in a fully assembled kit like this for the price listed on the website.